Alright, so I'm gonna do a proof of the law of sines. Now, let me just draw a triangle right here. As you can see, I have a side right here, and I'm drawing another one right there. I'll try and make it a little oddly shaped so you can see that the law of sines can apply to any triangle, not just a very neatly shaped triangle. Now let's say we know the following information. Let's say that this angle right here is alpha. This side is A, which the length of A would be length A. And let's say that this angle right here is beta, and that the length opposite to it right here is B. So now let's see if we can find a relationship that connects A and B together and alpha and beta together. Now let me draw. Hopefully the resulting relationship is the law of sines. Otherwise I would have to, rename the video. Let me draw an altitude for this triangle right here. So if I draw a line coming from this vertex right here, straight down, it's going to be perpendicular to the bottom side, which is opposite of the vertex. And because the altitude is perpendicular, it results in a 90-degree angle in both ways. I really don't know anything about the altitude except that I went from the topmost vertex right here, as I mentioned earlier, and dropped a line that formed a 90-degree angle with the other side. So what exactly can we do with the other line? Let me just say that this altitude, or the height of this triangle, would have a length of, let's say, x. So the length of the height is x, so we can find a relationship between x and beta. So if we look at beta, x is completely opposite to it, and A is the hypotenuse of the right triangle formed right here. So what deals with opposite and hypotenuse? So whenever we do trig, we should always write SOHCAHTOA at the top. So it deals with opposite and hypotenuse. Sine, right? So let's see the sine of beta. So let's see. The sine of beta here is equal to the opposite over the hypotenuse. Therefore, it is equal to this opposite, which in this case is x, of the hypotenuse, which in this case is a. And if we wanted to solve for x, and I'll just do that because it will be convenient for later, we can multiply both sides of this equation by a, and you get a sine of beta is equal to x. So as we can see, that got us someplace, I guess. So now let's see if we can find a relationship between alpha and beta and x, the other triangle right here. Similarly, from the previous triangle that we saw, if we look at the right triangle, because, it's a right triangle again, x here is relative to alpha, is also the opposite side, and now b is the hypotenuse. So we can also write that sine of alpha is equal to opposite over hypotenuse. The opposite side in this case is x, and the opposite hypotenuse, as I stated earlier, is b. So let's solve for x again. We would multiply both sides by b, and you get b sine of alpha is equal to x. So now exactly what do we have? We have two different ways to solve for the amplitude, or the height of the triangle that I dropped down earlier. Well, we have sine of beta is equal to x, and b sine of alpha is also equal to x. Well, we know that if they're both equal to x, then both of the equations above are also equal to one another. So let me just write that down real quick. So we know that a sine of beta is equal to b sine of alpha. And now if we divide both sides of this equation by a, we get, what do we get? We get sine of beta is equal to b, and sine of alpha over a. And now if we divide both sides of this equation by b, we get, let's see here, sine of beta over b is equal to sine of alpha over a. So, as a result, you get what is called the law of sines. Sine of beta over b is equal to sine of alpha over a. So this law is basically saying that the ratio of beta to b is completely equal to the ratio of alpha over a. So as a result, as I said earlier, you get the law of sines. And this would also be true for the last side right here. So if we draw in, let's call this angle right here theta, and the opposite side to the angle, let's call it c, the ratio of theta to c would remain constant with the other two equations that we have already solved. So that's pretty much the law of sines.